we finally reached day 5. So at this point, you should have already attempted all of these problems, and now you're just reviewing. So day 5 is your independent practice where you're writing and comparing numbers in scientific notation. So number 1, which of the following expressions is equivalent to 5,710,900? So scientific notation, we need a number between 1 and 9. The only thing that makes sense here is 5.710, and we have to put 9 in there as well because it's also there. And then you multiply it by 10 to the something power. So we're going from a smaller new number to the original large number. So we know our exponent needs to be positive. And we would move this decimal place 1, 2, 3, 4, 5, 6 places in order to get back to our original number. So it should be 5.7109 times 10 to the 6th power, which is here. And if we do that, we would know we have 5.7109, 1, 2, 3, 4, 5, 6, and that's our exact number. Boom. We're good to go here for number 1. All right, number 2. The average distance from Pluto to the sun is about 6 times 10 to the 9th power kilometers. The average distance from Mars to the sun is 2 times 10 to the 8th power kilometers. The average distance from Pluto to the sun is about how many times as great as the average distance from Mars to the sun. So same thing as we've been doing in our previous days for this lesson. We have the farther distance over the closer distance. The one that's farther is Pluto, of course, and the one that's closer is Mars. So Pluto's scientific notation of the distance from the sun is 6 times 10 to the 9th power, and Mars is 2 times 10 to the 8th power. So all you have to do here is break apart your first factor and your second factor. All right, so we have 6 over 2 times 10 to the 9th over 10 to the 8th. 6 over 2 is equal to 3 over 1 times 10 to the 9th over 10 to the 8th. It's just our quotient rule. So we keep our base the same and subtract our exponents. That's 9 minus 8, which is 1. So we've just got 3 times 10 to the first power is 30 times. So it's 30 times as far is our answer here. All right, we move on to number 3. Last year, a business earned 4.1 times 10 to the 6th power dollars in income. This year, the business earned 2.05 times 10 to the 8th power dollars in income, which best describes how this year's earnings compared to last year. So you have to first figure out, when we're trying to figure out the difference or comparing two numbers written in scientific notation, you need to figure out which one's larger over the smaller number. Larger over smaller. In order to do that, the quickest way is to figure out which one has a larger exponent. We have 6 versus 8. 8 is larger, so our larger income is going to be 2.05 times 10 to the 8th power, and our smaller is going to be 4.1 times 10 to the 6th power. And since they said which one, all these answers have the word about in it, so we can kind of approximate the original numbers like the 2.05 and the 4.1. We can just approximate the 2.05 to be just 2 and our 4.1 to be just 4. So let's break apart our fraction. So we have 2 over 4 times 10 to the 8th over 10 to the 6th. 2 over 4 is a half, of course, and 10 to the 8th divided by 10 to the 6th is 10 to the 2nd over 1. So all you need to do now is you just simplify. So we have a half times 10 to the 2nd over 1 is 1 times 10 to the 2nd over 2. 10 to the 2nd is 100, so we've got 100 over 2, which is 50 times. The one that says it's 50 times as much as last year is C. This year, the business earned about 50 times as much as it did last year. All right, and I'm ready to move on to number 4. write the numbers in order from least to greatest. So the easiest way for me at this point to figure out or to sort these numbers from least to greatest is to just either choose to write them all in standard form, or you choose to write them all in scientific notation. Either way, it'll work for you. So we can just go ahead and do this. So I'll go ahead and choose to write the bottom two in scientific notation. So I'll have -2 times 10 to the something power and +7 times 10 to the something power. So I'm going from a small number to a bigger number. So I know that I ended up having to move my decimal point 1, 2, 3, 4, 5 times. But in order to go from this small number to a bigger number, I'd have to get from the bigger number back to the small number to get from scientific to standard. So I'm really moving to the left. That's a little confusing, but that's what we're doing. All right, and then here, negative whatever this number is, 1, 2, tenths, hundreds, thousands, 10,000, 100,000, millions, 10 million. So -2 10 millionths is actually bigger than -2. So I'm going from a big number to a small number. So I'm really going to be moving. I'm still doing the same thing though. I'm still going, I'll have this number 3, 4, 5, 6, and I have to move it over 1, 2, 3, 4, 5, 6, 7 times to get here. And since I'm doing it that way, I have to go from -2 to this other number, and it's gonna look smaller like in value, but it's really bigger. So this one's a little bit confusing. But in order to get from -2 to -0.2 10 millionths, then I really have to move to the negative or to the left. So this one's confusing, and I don't really like this one, but we're here. It is what it is. All right, so then I can go ahead and put these in order. So I'd have my negative numbers I know should definitely be on this side. I have 2 negatives and 2 positives. Negatives are definitely going to be smaller than positives. So I know I'd have my negative numbers over here and my positive numbers to the right. Okay, so I can look at my 2 positives, which are my 5 times 10 to the -6 and my 7 times 10 to the -5. Well, if I'm looking there, then I know that -5 is actually greater than -6. So I should have my 7 times 10 to the -5th over here and my 5 times 10 to the -6th here. Then I'm going to look at, and I'm going to erase some of this stuff because it's a little confusing to look at. Okay. Then I'm going to look at my negatives. I have -9 times 10 to the -3rd, and I have -2. Oops. And I have -2 times 10 to the 1, 2, 3, 4, 5, 6, 7. So the -7. I know the -7 is smaller than -3, so this will be my smallest one. -2 times 10 to the -7, and -9 times 10 to the -3rd. This question was very confusing, but as soon as you end up either writing them all in standard form or in scientific notation, if you do it in standard form, it's a little bit easier to see it, I would think, because you'd be able to see the place values and see how many zeros are before the numbers. That's probably way easier than seeing this, but that's okay. This is what I chose to do. So what you could do is you could either write them all in scientific notation or in standard form. Whatever you end up doing, just be consistent and then compare. All right, and that is it for number 4. Moving on to number 5. Cara was using her calculator to solve a problem. The answer that displayed was 1.6e plus 12. So this just means that is 1.6 times 10 to the 12th power. She knows that she entered all the numbers correctly. Why did the calculator give the answer it did? And what's the answer to Kara's problem? So when you see the e to the 12th power or to the plus 12, that just means it's times 10 to the positive exponent. Okay, the e is like, it just means exponent. And, oh, I spelled exponent extremely wrong. Exponent. And then the plus means that the exponent's positive. All right, so her answer is actually 1.6. E to the plus 12 is 1.6 times 10 to the 12th power. So all you do is you have your 1.6 and you move it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Add your zeros and you are done. All right, so this one is thousands, 10,000s, 100,000s. I just said that's super wrong. So 100,000, millions, billions, and trillions. Okay, so just her answer is 1.6 trillion. Okay, and it's 1600. Okay, yep, because we got billion, billion, trillion, and there we go. All right, in number 6, the length of a city block running north to south in New York City is about 5 times 10 to the negative second miles. The distance from New York City to Mumbai, India is about 7.5 times 10 to the third power miles. The distance from New York to Mumbai is about how many times the length of a New York City north-south block? Okay. So it said the distance from New York to Mumbai is about how many times? So that one's going to be the larger one over the smaller one. And that's going to be our New York to Mumbai over the north to south. Let's just say that. All right, so our New York to Mumbai is 7.5 times 10 to the third power. And our city block north to south is 5 times 10 to the negative second. So just as we've done previously, you have your numbers from 1 to 9, and then you have your powers of 10. So you'd have 7.5 over 5 times 10 to the third over 10 to the negative second. So go ahead and simplify. So you do 7.5 divided by 5. So go ahead and do that. I just use long division. I haven't used a calculator this whole lesson. It's not really necessary. So 5 goes into 25 5 times, and I'm done here. So that's equal to 1.5 times 10 to the 3 minus negative 2 is 3 plus 2, which is 5. Okay, so you've got that. But this is in our scientific notation, so it's helpful, but we need it in standard notation or standard form when they ask you about distance. So then you just go ahead and simplify. So 1.5 times 10 to the 5th power, you just write your 1.5 and move your decimal place 5 places to the right since the 5 is positive. The exponent 5 is positive. 1, 2, 3, 4, 5. Add your placeholder zeros. So it's 150,000 times the length. That's our answer. And we are done with this lesson. Yay. All right.